Transformations review. Okay, 8th graders, today we're going to take a quick look again at the types of transformations to help us as we go into our next unit, which is congruence and similarity. So however you're taking notes, have your notes page ready to go. By the end of today, you should again be able to define the different types of transformations and use them to make congruent figures on a coordinate plane. What are the different types of transformations? There are 4, and you have them listed on your notes page. We're going to start with a translation. Translation is how a figure slides on the coordinate plane. To move your shape horizontally, you add or subtract to the X part of the ordered pair. To move vertically, you add or subtract to the Y part of the ordered pair. Our second type that we learned about was reflection. The reflection is your mirror image. It's like looking in a mirror of your original figure. If you reflect over the x-axis, you take the opposite of your y coordinate in your ordered pairs. And if you reflect over the y-axis, you take the opposite of the x in your ordered pairs. Rotations, 3 kinds, and that's turning a figure about the origin. Remember, we talk about going clockwise, 90 degrees clockwise. You take the opposite of your x coordinate, and then you switch the x and y in the ordered pair. For 180 degrees clockwise, you take the opposite of the x coordinate and the opposite of the y coordinate. No switching happens in 180 degrees, just the opposite of x and the opposite of y. And then 270 degrees clockwise, which is also the same as 90 degrees counterclockwise. You might want to make a note of that. Same as 90 degrees counterclockwise. You take the opposite of your y coordinate, and then you switch them. So y would come first, and then x in the ordered pair. Our last kind of transformation was dilation, and that's using a scale factor to enlarge or reduce a figure. So if we're going to enlarge, that's actually multiplying by a whole number. You're making the figure bigger. The opposite of that is reducing. If you're going to reduce, you're multiplying by a rational number, like 1/2, 1/4, 2/3. You're making it smaller. Okay, so those are the 4 types of transformations that we studied in our transformations unit. Now let's see if we can figure out. I'm showing you 4 images on the next page in your notes. What transformation is it? So looking at this first one, what do you notice happening? Triangle ABC in blue, and then we have triangle A prime, B prime, C prime. It appears to have gotten bigger or enlarged. What transformation is that? You are correct. It's a dilation. I know this because triangle ABC is similar to triangle A prime, B prime, C prime. Same shape, but different size. The pre-image was enlarged by a K of 2. Remember, scale factor can also be called K. All right, second picture. What transformation do you think is happening here? Our original is triangle ABC. And then we have triangle A prime, B prime, C prime in green. If you said a translation, that should say, a translation, you are correct. I know this is a translation because triangle ABC is congruent to A prime, B prime, C prime. The pre-image moved down 2 and to the left 3. You know it wouldn't be a regular day in Mrs. Benoit's class if there wasn't a mistake in the notes. So there's your mistake. That should say translation. All right, how about the third image? Our original, triangle ABC, and then our green, A prime, B prime, C prime. What transformation do you think is happening there? If you said rotation, you are correct. I know this because triangle ABC is congruent to A prime, B prime, C prime. They haven't changed size. That was the same on the last one too. They didn't change size. They are congruent. But you can see that the pre-image was rotated 180 degrees which means take the opposite of X and opposite of Y in each ordered pair. All right, and our last one, original is blue. We don't have letters this time. And then the new one is green. What do you notice happening? This time you can see the ordered pairs. Hopefully you notice that in each of the ordered pairs, the Y coordinate becomes its opposite. So when does Y become opposite? That's right, in a reflection. I know this because we reflected over the x-axis, which you can see right here, which means take the opposite of Y in each ordered pair. And the triangles are still congruent because we did not change their size. That was your quick review of transformations. If you have any questions, write them on your notes and I'll look them over after you submit.